Hi, everyone. Thanks for joining us for our next session, Building Custom LLMs for Production Inference Endpoints. My name's Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. And while we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer. Our session is being recorded. It will be available to view on demand within 24 to 48 hours right here on our Microsoft Reactor YouTube channel. With that, I'll turn it over to our presenters. Thank you so much for joining us today.
Thanks, Anna. Hi, everyone. I appreciate you joining us. We'll do the customary good morning, good afternoon, good evening, regardless of where you are. I know there's a lot of things competing for your time. And so, yeah, thank you very much for choosing to spend it today with us on this session, where we will be going through, building custom LLMs for production inference endpoints. And we really strive to keep these technical for folks like yourselves. And so we've got some great expert speakers in this space that are in the front lines with customers implementing LLMs in production. And so, we've got a lot to get through today, a full jam-packed agenda. And we'll take a few minutes just to introduce ourselves, who we are. And then I'll set the stage. And it's important to set that foundation for, what we're going to discuss and dive into when it comes to custom LLMs in production or LLM ops as well. So I'll cover some of the best practices that, we want to strive for. We'll also look at some of the challenges that, you yourselves might face on a day-to-day basis. And also then touch on who are we and how do we play as a Microsoft partner in this equation. And so then we'll get into specific, deep dive with our guest speakers around, dealing with and mitigating hallucinations and harmful language. And then also, deploying and serving those LLMs in production, mitigating the risks and constraints of LLMs and making sure that we're optimizing that performance. So we're not just churning through, some of our sort of cloud, budget and dollars. We definitely want this to be interactive. The more questions and interactive we get, the better. That's what we're here for. So please, if you've got any questions or anything that we can help answer or clarify, definitely, post it in the question queue and we'll try and get to it. We also have some time carved out at the end for Q&A. So if you want to keep your questions for the end, that's fine as well. So again, really appreciate you being here. I know this is Halloween. This is not a scary mask. This is what I actually look like. But I'm Martin Bald. You may have seen me if I do my Troy McClure piece. You may know me from other Reactor presentations. But yeah, it's great to be back here. I've had over 2 decades in the tech industry, 25 of those years, with Microsoft. And the last part of my career was spent in DevRel. And I will say without hesitation, that was the high point and the most enjoyable part of my career, is connecting, engaging, collaborating with experts like yourself in this space. And so, yeah, I've done a lot of, webinars, hackathons, etc. More than I care to sort of go into. But again, this is me. I'm going to introduce or bring in our next expert speaker. Kevin, would you like to introduce yourself, please?
Absolutely. Hey, everyone. I'm Kevin, founder and CEO of Pegasi, and we're building the quality control layer for Gen AI. I'm a former data scientist at Boston Consulting Group, spent 4 years building conversational AI solutions on behalf of Fortune 500s and FIs, and saw firsthand the challenges, both from a technical and business perspective, of deploying these models into production. Very quickly, I studied at Oxford, a couple years in computer science department, and then attended Harvard as well. Super excited to talk more specifically around hallucinations, harmful language detections, and how we can build trustworthy systems with online listeners.
Awesome. Thanks, Kevin. Great to have you here and great to have our partnership with Pegasi. We're going to bring in our next expert speaker, Jason. Please introduce yourself.
Thanks, Martin. Hi, everyone. I'm Jason McCampbell, and I head up architecture at Wallaroo. I have a lot of background in high performance and distributed computing, and I've been around long enough that originally AI was a lot of deterministic algorithms, search optimization, and everything. So did a lot of that, and then over the last number of years, started looking at how do you apply machine learning to areas like semiconductor design, and then a number of years ago joined Wallaroo and jumped at the chance when I had the opportunity, and I've been here ever since.
Awesome. Thank you very much, Jason. Great to have you here. I really appreciate your time, and looking forward to diving into some of these topics. Now, as I talked about at the beginning, it's important for us to, I'll take a few slides here. I really want to make this about, the code and the content and the showing and telling, and definitely don't want to get into the death by slide point. But, one of the things that it's important for us to make sure that, we set the foundation here for the context of what we're going to be talking about. So I will go through a handful of slides here quickly, just to set that foundation so that we get that understanding of, what does it mean for us when we talk about, building, best practices for effective LLMs in production. And when we work with customers, like yourselves, we collaborate with them, we really sort of strive to, get to that, effective, platform, just to make sure that as customers are looking to get into the Gen AI space, we've seen a great rush towards this and implementations, but also as customers look to, customize LLMs and move away from some of those sort of canned endpoints that we've seen, and really sort of get into tuning those, models for their own specific needs. And it's the same story when we compare it to traditional ML. We've all seen the analyst reports. You've probably seen the Gartner one where 90% of AI projects fail to make it in production, and the ones that do, I think something like 65% fail to add value or back to the organization. So in that respect, building that best practice is all about that speed, that quality and quantity. We want to make sure that you realize your existing investments for this custom LLMs. We want to make sure that you can leverage the integrations that you already have in your ecosystem that you've built and put together, but then also have that agility and flexibility to iterate quickly, and make sure when it comes to LLMs that you're monitoring them effectively. They do drift. They do, have a habit of, giving, wrong answers to folks, which affects your credibility. So you want to make sure that you're monitoring those LLMs effectively in production, but then also make sure that you're doing it proactively so it doesn't become an after the fact issue. And then also make sure that you're not creating any sort of disruption to your, production operations, and result in exposing any of the bias or performance issues that we'll talk about later in this session. And the other element of this is when you build that performance and that monitoring into your practice, is to make sure that, hey, how can we scale this? How can we build upon this and have multiple models for different contexts in our business, and really sort of take advantage of these as we move forward. And so there's a bunch of challenges that we have to deal with, and we're probably dealing with right now for these. And as I talked about at the beginning, those analyst reports of failed deployments fail to sort of turn value to the business, and that time to value is critical. We have this in theory, but we don't really have it in practice. And so what we really want to sort of strive to do is make that sort of practical element, and make sure that we're removing that complexity, we're removing that sort of engineering overhead to not just build the infrastructure, but then also scale it, and then also have the capability to bring in those custom LLMs into production for the infrastructure that we have in place already, and making sure that we have control over that, and maximize that performance, and not become yet another request to, the DevOps or the IT ops queue, so that, as a data scientist, you have the tools, you have the intuitive tools and, familiar tools with which to, deploy, serve, monitor, manage, observe these models by yourself, and make sure that you're proactively accounting, for those, challenges and bias, which, we've seen some unfortunate public instances, out there with, businesses, actually going to court, losing a lot of credibility with that, reduction in, that sort of compliance or bias issues. Now, as Wallaroo, this is where we come in. As we're a Microsoft partner, we're also in the Azure marketplace as well. And so one of the things that we focus on when we work with customers and data scientists is, we help focus on that efficient deployment, making sure that, as I talked about, that we come in where you are on your journey, and we can meet you there as a customer, not just with your infrastructure, but also with the expertise that you have in-house to help make sure that you're up and running quickly in a framework that is familiar to you, and then also give you the capability to do that proactive monitoring and that iteration on your models, as well as at the same time optimizing that performance for that production and really utilizing infrastructure that you have, whether it be, GPUs, CPUs, or you want to blend those together so you can maximize the infrastructure that you have available to you. If anybody's ever going to ask for budget, for finance, we know definitely some of the, the grief and the challenges that takes. And so if we can do that optimally, then it's a huge bonus for us and we can move forward. Now, I'll quickly dive into a couple of these components when I talk about, monitoring and performance. And this will tee us up for our experts, for Kevin and Jason. They will shine a bright light on this. But essentially, when it comes to deployments, and one of the techniques, that is available to limit those bias and hallucinations is retrieval augmented generation, and you might have heard it as RAG. And it is right now, one of the most popular techniques out there to limit, bias and hallucinations. If you've been on any discussion queues, threads, LinkedIn, you'll see the popularity of this in, our sort of developer and data science communities. So we are, we work, within the context of this, where we can limit that bias and hallucination using the idea of vector index databases for deploying those LLMs into production. And we can work within a specific context with customers so that these responses that you get back to the end user are not deviating from the realm of answers that they can provide, and making sure that the answers that you're getting are accurate, credible, and you're not sort of drifting into any bias or compliance issues. We also want to make sure that we have a tight integration with that end application that is powered by the LLM, as well as that underlying vector database, so that as you're building that automation into that LLM ops process, you can continue to enrich these databases. Make sure that as things drift, that you have that authoritative knowledge to make sure that the folks at the end are getting the right accurate responses. Now, when it comes to monitoring as well, there's another technique that we'll talk about, and this is where Kevin will come in and really sort of dive into this. These are Wallaroo LLM listeners. If you were on our previous reactor session in the summer, you might have seen us do a sort of quick demo on this one. But essentially, this, the Wallaroo listeners help with that effective monitoring from the perspective that, we can help, look at specific metrics around, harmful language and toxicity and things that make sure that we're not out of compliance, and also make sure that we have the quality of response that we're generating, and we have a healthy, model response to the end user. The other element that's great with the listeners is that customers can fine tune these for specific context. They can, if you're in finance or government or legal or another sort of specific industry that has specific needs for your domain, you can fine tune these again to improve the accuracy and remove those hallucinations. So, for example, we did work with one customer. We helped them with interactions of customers with chatbots, and then we used that analysis to then see, is this a potentially qualified customer, and then do they go into the outside sales queue, or do they go into some other nurture queue as well? So you can then prioritize some of that, based on some of that sentiment analysis. And you can also score these alerts and metrics on the fly. And so that interaction becomes much more valuable to the operator. They can, really get into that proactiveness and making sure that we can iterate and keep these models tuned and driving that effective value that we talk about. Enough of me. So I'm going to, Kevin, please come on. I think this is where we get into the really interesting part of this conversation. I'm going to hand it over to Kevin. Kevin's going to take us through Pegasi and really sort of drive into this context. Kevin, over to you.
Amazing. Thanks so much, Martin. And this is really great. I think we're really excited about our partnership here between Wallaroo and Pegasi. We're very much powering the online listeners. And so what we hear is that, obviously Gen AI is very useful, but when it makes mistakes or hallucinations or toxic outputs, they're highly costly, right? And so for enterprises, especially like financial institutions and other regulated firms in particular, these mistakes can leave them open to severe financial losses, legal liabilities, and brand damage. And so it's one thing to try to, like before production, look at trying to understand the different areas where Gen AI can make mistakes. But post-production, given the stochastic natures of these models and how confident they are, it's really important to try to catch these errors in real time, and what we do, correct them as well. What we hear from a lot of customers as well in particular, if we go back real quick to the slides, is that there's some challenges in RAG implementation. Although there are claims of, for instance, like hallucination-free solutions out there, like if you look at Westlaw from a Stanford paper or others, despite these, AI researchers at Stanford University still see about hallucinations between 10 to 30% of the time, and still in double digits. And this also goes across industries. If you look at finance bench, looking at regulatory reports, these, even if the ground truth existed within, it's even higher. And so it's really critical to be able to monitor these in production and to provide the remediation around that. So happy to share an example through a demo, and then kind of walk through a little bit more through a notebook and how that kind of works, given that we have more of a technical audience here. So let's dive into it. So very quickly here's an example with our sandbox environment. And so to just illustrate this, we have three main inputs. This is typically used in a RAG environment, but can also be used in an agentic environment. And the main idea here is you have the prompt, which is the original user query. You have the AI completion. It could be an OpenAI model, or it could be Llama 3. And then lastly, you have grounding sources, or in other words, the context that's being used from your RAG database or other evidences that you've gathered here. In this example, we're looking at NVIDIA. We're looking at the third quarter earning reports here, and we see some key data that's important here, right? Revenue, net incomes, earning per shares, and we have a prompt that's generally being used. Now, we have a pretty confident response here, in which NVIDIA reported revenue of $20.5 billion, a net income of $10 billion, and the EPS of $4.20 for the third quarter 2024. And we see that the net income saw a significant decrease. We know intuitively NVIDIA has been crushing it. So once it goes through our system, not only do we detect that there are ungrounded claims here, but we're able to also redline, more importantly, and build trust with users by not only providing the corrected response in green right next to it, but also provide the reasoning and explanation around it, and the so what, right? First, senior executives and stakeholders. In this example, we see a significant discrepancy of more than $2 billion, or 11.6 lower than the incorrect figures. And we do this not just for numbers, we do this for also qualitative errors, which are equally as important, especially if you're building in certain use cases in like health insurance, or you're looking to do so around brand damage in doing so. One of the other challenges here is because the models are so supremely confident, it's important to really be able to distinguish when the model is a little bit less confident, right? And being able to provide a qualitative score that's high, medium, low is really important for whether or not a human expert should come into it and review further. And it's really important to have this human in the loop and subject matter expert to really have trustworthy systems in production as well. So I will now shift gears into what we've done with Wallaroo in particular. And so, as you can imagine, like we're one of the listeners, right? We partner with them to do so. And essentially, we have a suite of both input and output listeners that can work really well in between your LLM application and as you go into production in doing so. And so we have an example notebook just to bring it to life with some examples around RAG hallucinations, toxicity, security and compliance controls, which are also important in production and being able to do so. It's a very simple notebook, a couple line of codes, and then we can look at some examples. In this example, we're looking at quantitative examples for a finance bench, right? You have the prompt, you have the response, context, and we're able to see different risk scores in real time. A scalar value between 0 and 1.0, or 1.0 leads to a severe risk, and 0 is very little risk involved as well. You do it for qualitative answers as well. We get this value, and this all can be displayed right back in Wallaroo's environment in terms of their platform. You can see these integrated live as well. And so one of the examples that we've worked with in particular was around toxicity. Toxicity is challenging, especially in regulated industries like health insurance, because not only like is it ethically wrong if AI spews responses that can lead to potentially inequitable business decisions that are coming out of it, but there are severe financial penalties and reputational penalties that comes with it in particular. So if we look at some examples around pretty more straightforward ones around whether or not a certain gender group needs more health insurance than others, we can see quickly not only is there a high confidence in that this is toxic, we provide the reasoning as well in the label. There are more nuanced ones looking at, for instance, specific GINA acts like genetic information here in the United States that must be compliant in order to actually go to production as well. Lastly, as we talk a little bit more, we have security controls. Security and privacy is top of mind as people are going to production. Building trustworthy systems are very important, but data privacy is equally as important. And so being able to not only look and provide the alignment and security controls, but redact PII information, PHI information, and sensitive substreams are so critical to get to production as well. So I will pause here and I'll bring it back to Martin.
Thanks, Kevin. I think you might have answered this just at the end there, but we have a question from Naveed where he was asking, like, how do we address privacy issues while implementing LLM listeners?
Yes, absolutely. And so I mentioned it towards the end, but the main idea here is to look at the different security controls and governance control that are so important to your steering committee and your overall security risk profile for companies, and being able to implement them in production. And so whether that is around sensitive information for customers and users, such as PII and PHI, or that certain regex patterns or certain sensitive substreams, whether around copyright information or specific types of, there's different types of controls that are offered here to make sure that in production in real time, you can catch those stochastic outputs and make sure that before it goes to an end user or goes to the wrong areas in terms of like API usages, in case you don't want to send to an LLM, we can do that before or after and redact the information in real time. And so an example of doing that is these redacted information here. You can look at the redacted person, emails, phone numbers, and you can look at the risk scores in real time. So hopefully that answers your question.
Great. Thanks very much, Kevin. Naveed, thank you very much. Great question. I appreciate you getting involved. And yeah, Kevin, I think we're going to bring in Jason now to continue this conversation on, how do we optimize and for performance and the credibility of the responses that we're giving out to folks with, the LLMs. Jason.
Thank you, Martin. And thank you, Kevin. That was a great talk. And bring it back to what Martin was talking about earlier. We're really focused here on how do you get a model into production and separating production from prototype and get something up and running. And what Kevin was talking about is one of the critical issues. In fact, I was putting together a quick code assistant demo the other day, and a couple of test cases went through, and then I gave it some Python code and asked it to give me the next couple lines of code to complete the function, and it did correctly. And then it started talking about Scottish football. I don't know where it got that from. It was interesting, but it surely wasn't code. And it really critically, it wasn't what I wanted to go back to the customer with. So, one of the critical aspects is monitoring and in the loop monitoring. So we need to get the model correct. The other two aspects are, can we monitor it offline over time so that we know that when the results are good today, are they good tomorrow and next week and next month? And then, of course, can we do this all cost effectively? So I'm going to walk through what it looks like to stand up a production grade pipeline here with a model and incorporate some of the things that we've been talking about. So I'm going to start off with RAG. And as Martin said, this is retrieval augmented generation. And what we're doing is pulling in some context to the model, and you can see it at the bottom here, and giving the model some additional context to work with, some additional information. Intuitively, I think about it like having an expert, human or model, having to memorize the entire set of information that they're going to be queried on, or letting them cheat just a little bit and look into the model and look into the reference material. So to jump into the demo here, this is a notebook. It probably looks familiar to any of you who have watched some of our other reactor demos, and there's a reason for this. We really want this to be consistent. It's a similar interface for the AI team. And we're going to start off with just importing the Python packages we want. The critical one being the Wallaroo SDK. I'm running this from within the Wallaroo cluster, but the SDK works just as well in other notebook environments from Visual Studio Code or anywhere else you want to run it. And then we're going to connect to the cluster and jump in, and I authenticated earlier here with it. So now the first piece is I'm just going to deploy a LLama model with RAG augmentation. And then we'll move on to the monitoring aspects. So the first thing I'm going to do is upload my embeddings model. And you see I start off here, I'm going to just define a schema, just telling it what the inputs and outputs are. So an input text string, and I'm going to get back the embeddings as well as the text prompt. And I upload a zip archive, which has just a little bit of my code, and the model waits itself. And I'm using the Wallaroo custom framework. And it's really the upload model command that's the key piece here. This is our automated packaging framework. So just with these inputs, I'm able to take this model, automatically package it, and get it ready for deployment. If we come down here, now we also want to have the LLama model, and we want to augment it with the RAG capabilities. So it's the same thing, we define the schema, and we're going to give it now our LLama model to run here. And I'm going to dip into the code just a little bit. I'm not going to do a full code review here, don't worry. But we're going to jump in, and we have a class. It implements the inference interface. And really, the key part of it is the predict method here. And all we're doing is we're extracting the prompt and the embeddings. We're going to call our vector database. In this case, we were using MongoDB, but it can be any database that you happen to be wanting to use. And then we're going to generate our prompt. So we're going to format the prompt and the context together and send it in. The key part to this is a lightweight infrastructure. So there's not a lot of boilerplate code for you to write, but you have full control over what vector database you use, how you want to use it, and the sort of model that you want to call. So we hop back here, we upload this model. Now we have our embedding model and we have our Llama model with RAG enablement ready to go. So now let's deploy it. This block here tells the system what resources we want to allocate. How much memory, how many CPUs, do we want a GPU or other sort of hardware accelerator? And then we're going to build our pipeline and deploy it. You can see what we're adding first, our embedding model here, and then our Llama model, and we deploy it with the deployment configuration. What this is doing is now we're taking these two models, we're deploying them as a microservice into Azure or other cloud environments with networking and load balancing and everything set up so that we have an endpoint that now we can start to work with. And this is a full RAG-enabled endpoint. If we come down here, we can test it out, asking for some action movies, and we call the infer command. And we get back Unforgiven and another set of movies here. So the key is, what we've just done is taken two models, deployed them as an integrated pipeline, as a microservice here. And we've done it without having to build containers, without having to deal with Kubernetes infrastructure, without having to set up the networking. All of those software bits have been automated to allow the team really to focus on where they add the most value, which is on the business objectives and on building these models and understanding the data science here. So we've deployed a RAG model, and as both Martin and Kevin have said, RAG can really help with improving the quality of the results coming back. It gives the model some reference material to work off of, but it's not sufficient. It'll improve the quality of the results, but in many industries, that's still not the quality level that is required. So let's talk about putting an inline listener in here, just like what Kevin was talking about. So now this code is going to look very similar here, and that's the point. Again, we're going to define the schema, and we're going to upload a model. And in this case, we're going to be calling OpenAI's GPT 3.5 Turbo API. Wallaroo is happy to work with it, whether you're deploying the model in your own environment using your own hardware for privacy and security reasons, or whether you want to call an external API. So we're going to upload this model. Now we go through here. Same thing again, we're going to call upload model, but we're going to use a summarization model here. And what we're going to do is we're going to deploy this as a monitor on the output of OpenAI's result. So same process. We set up the hardware resources that we want to use, and we're going to build up our pipeline. So as before, we add the GPT model step. We're going to add the summarizer now as a listener receiving the output from GPT-3. But we're going to add one more step called the validation. And in this case, the summarizer returns a score indicating how similar the result is to the input prompt. What we're going to say is if this output score is less than 75%, we want to set a flag called incorrect summary. Now, what we do with that depends on our use case. You could have a use case where maybe the user interface says, puts a little indication that, hey, this result may not be that high quality, so don't necessarily trust it. In other cases, it could be don't even show that, and you direct the human user, your client coming in, over to a human representative to give a better answer. But the point is that when the request comes back, it has this flag set. And we can see it down here that we've injected a summary text here, and it runs to the pipeline. We get the output text. We also get the output score, 73%. That triggers the anomaly, and the anomaly flag is set. And then again, the consuming application can decide what it wants to do with that. So what we've just walked through here is the first part of what we talked about in terms of deploying LLMs in production is that we've taken a model, we've added RAG capabilities to it, and we've added an output monitor that is able to detect when the summaries, when the summary doesn't match and flag it as a potential issue. Of course, you could have multiple monitors here, and you could use much more advanced models that are monitoring the output, like what Pegasi is building. So with that, I'm going to jump back to the slides here, and
Actually,
talk
Jason,
about the next.
before you do that, before you do that,
Sure.
sorry to interrupt. We've got a question from the audience, and it's a great question, given that you're showing the notebook with Python code. The question from Dennis is asking us: is Python the only language that I can use, or is it possible to use C# or another language?
Oh, that's a great question. Absolutely, we support just about any language out there. Our SDK that I'm showing here is in Python, and this tends to be the most common language that's used by data scientists as far as setting up the models. However, our Wallaroo has 3 parts to what we call our integration toolkit. This SDK is one. We also have the dashboard that I'm going to show in just a minute. And the third part of that is our standard HTTP-based APIs. And those APIs are what underpin both the SDK and our UI. So we force ourselves to dog food our own API. We use the same API that's available to all of our users. So if you wanted to call the inference endpoint from C#, it's just a matter of an HTTP request call, and you can pass the same data in. Same thing if you're using any other language. And of course, all of the capabilities as far as what I showed, building up a pipeline and deploying it, that's accessible through our APIs and from C# or other languages as well.
Fantastic. Dennis, thanks for your question. I hope that helps. I appreciate you getting engaged. Jason, I'll hand it back to you.
Thank you, Martin. Okay, so very quickly on this slide, Martin talked through it, but there's really 2 parts to the listening here. One is what Kevin was talking about, where you have the critical inline monitoring, where as the response is generated, we're either evaluating the quality of it, like what I showed, or even auto-correcting it, as what Kevin showed, and that's the result that can go back to the users. The other aspect of monitoring is offline monitoring, and this is where we accumulate all of the inputs to all the requests and the generated responses, and process them in batch, not in the loop with the responses, but say nightly or weekly. And that's what we're showing here. And you can see there's a little box called logs. And Wallaroo has a high-speed database where we accumulate all of the inference requests and results and store them away. So I'll show our dashboard and also kind of what this monitoring process looks like. So if you want to switch over to the UI here, what we're looking at is a toxicity monitoring pipeline. And this is not one that's running, again, in the loop with user responses, but instead it's going to process the inferences that have gone through the pipelines that I showed and analyze them for toxicity. If we go into our model insights tool here, we have something called assays. And this is taken from the scientific domain, where you're running assays, you're running tests on samples and comparing them against known results. In this case, our known results are baselines that we established when we trained the model. And now we're sampling batches of inference inputs and results, and we're comparing them to see how they match up against the baseline. And we're doing a statistical analysis of that. So if we look at this toxicity baseline, and I'll jump back to when we set up the model here. What we're seeing here is not the toxicity level, but we're seeing how closely these batches correlate to what we trained against, what the similarity level is. And what you can see is we were still getting the toxicity checks to work, and they weren't working particularly well. They were very different than the baseline. But we went through an iteration, we improved it, And then after a little bit of time, you can see now we're getting a bunch of green readings, meaning very similar to our baselines. And some kind of jump up here. And if we want to push into one, we can see how these statistical distributions, how these samples compare. You can see in the gray and the blue is what the original baseline looked like. And we've dropped off on the left side and the samples kind of pushed to the right. And this push to the right means a little bit more toxic. We don't see huge outliers to the right, meaning that it isn't an extremely toxic response, just a little bit more toxic. So what we're looking for is there an increase over time or does it remain consistent? What we're also looking for is automated results so that people aren't having to sit here and watch the dashboard every day. But what you want to do is be able to establish a threshold so that you can understand that this model is performing as you expected the next day and the next week, like I said. Or do you start to get an uptick over time? And that uptick could be a change in user behavior, a change in the RAG database, whatever it may be. And suddenly the results aren't quite consistent and it's time to go look at them. Because it's a lot better to get an alert and look at it as it's creeping up than when management gets an alert from the customers and comes and says, hey, do you know what your model is doing? So I'll take a jump now back to the slides. This is the last slide. I know nobody likes to look at them here, but I want to talk about the third pillar of production. So we talked about model result quality and inline monitoring and auto correction even, as well as the ability to monitor the results. But then we also have to be able to, of course, do this in a cost-effective manner. And I'm always amazed by how many people look at it. They start a model, you get into production, and then you get the bill, and you go, wow, okay, well, that's not going to work because we can't do that. We're not going to get an ROI out of this. It's going to be too expensive. So what can we do to improve the cost effectiveness of these models? And there's a lot of different options here. There's tools like Llama CPP, which are very effective at running models, particularly a little bit smaller ones, say under 10 billion parameters on CPUs. You can run a quantized model, and if you're not in a latency sensitive application, such as batch processing, the toxicity model, something like that, you can get a very big cost advantage doing this in some cases. You can trade off even ARM and x86 processors. On the other hand, tools like VLLM, we've seen very good results in terms of improving the efficiency on GPUs and make better utilization of that expensive hardware. And really, these two tools are an indication of where the industry is going and where Wallaroo has been for quite a few years, which is, after you've trained it and everybody was focused on training costs, inference costs are going to be the really big thing. Hopefully you spend a lot more on inference than on training because it's the inference where you're getting the value out of the system. So we're seeing more and more technologies for improving inference efficiency. Of course, the best way to save on costs, more than even efficient hardware, is if you can turn the hardware off. So auto scaling. Can you increase the amount of resources that you're using as the load increases, and then back it off when you're not? And of course, that auto scaling, how you want it to behave depends on whether you're doing batch processing in the evening, where latency doesn't matter. You really want to optimize for cost, or are you looking at real-time requests where you still need to meet some KPIs in terms of user response time? And then the last aspect is dynamic batching. And this is an interesting capability where if you can combine multiple requests into a single request that goes into the model, you can get some big efficiencies out of the hardware here, because compute hardware really likes to work on large arrays, large matrices, large loops where there aren't a lot of conditionals. So if you can pack multiple requests in and make the matrices larger, you can use the hardware a lot more efficiently. And we can see that over here where the gold is the dynamically batched requests, where if there's a couple of batches or a couple of requests pending, we can group them together and run them together. And in the blue, where we're running them singly. And what's interesting is you see this big wall of blue over on the right-hand side. Those are requests that timed out, that they didn't get processed within the the time limit that we set. So not only is dynamic batching reducing the average latency here, but it's also using the hardware much more efficiently, such that none of the dynamically batched requests timed out. So we're improving the throughput and utilization, reducing the costs through this dynamic batching. So that's all I had today. Thank you for listening. And I just want to reinforce again, what we went through is, in order to get models into production, not just prototype, but really out into production, there's 3 keys here in terms of getting high quality results using the inline monitoring, like what Kevin and Pegasi are developing. And then can you monitor that over time to understand how the results are changing? And can you do that cost effectively so that you get the ROI that you're looking for out of your models?
Awesome. Thank you, Jason. That's fantastic. I think when you're talking about latency there, I think you might have had a little bit of latency issues earlier on in your talk there, but no problems at all. Yeah, thanks everyone. I really appreciate the time here. And as we've sort of gone through, just to recap, where we talk about, at the beginning about building effective LLMs in production and, customizing those LLMs and that capability of, not treating, monitoring or, performance optimization in isolation, that it is part and parcel of a whole LLM ops practice. And, we can then hopefully take that theory that we talked about and put them into practice with some of the techniques and capabilities that you've seen here. If you want to try these for yourself, we've got a free community edition, no strings attached, no license expiry or anything like that. You can even use your GitHub code Spaces allowance for that. And as I mentioned, but also in the Azure Marketplace, we have a number of different inference servers that are free up there, and also that community edition as well. And Kevin is in the process with Pegasi to putting some plans up onto the Azure Marketplace as well. So look out for them in the future as well. But you can also reach out to me. My email's at the bottom. As I said at the beginning, a highlight of my career so far has been working in DevRel and engaging with folks like yourselves. Please, by all means, reach out. Let me know what you want to see in the future or any other sort of stories that you want to tell or discussions. I'm happy to engage with you. Thank you to our speakers. Thank you to Anna and the Microsoft Reactor team. And also particularly thank you to yourselves for joining us. I know there's a lot of things competing for your time. We do appreciate you taking the time to spend it with us here today and look forward to future sessions with you. Thank you and happy Halloween and have a good day.
Thank you all for joining. Thank you so much to our speakers for a fabulous session. We are always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. Today's event code is 23965, and we will see you at the next one.